All right, let's do some examples after that long-winded tirade I went on. Let's utilize it. So we got 2 sine cubed of x is equal to sine of x. So we're not going to fall for that shit. We're going to subtract that sine of x over to the other side. Right? We're not falling for that. We're going to set it equal to 0. We're going to solve. We see some pictures match. Sine and sine. All right, we would be doing this as 2x cubed minus x equals 0. You'd rip out the x, be left with 2x squared minus 1, right? That's what would happen if you were doing some algebra. That's what's going to happen with our words. So we take out that sine of x, we bring it to the front, and we're left with 2 times sine squared of x minus 1 is equal to 0. We factored it. Good freaking news. So we use our zero product principle to set these two things equal to 0 and solve. So we say, well, if sine of x is equal to 0, the whole thing is equal to 0. Also, if 2 sine squared of x minus 1 is equal to 0, the whole thing equals 0 by the zero product principle. So on the left, our sine of x equals 0, sine of x equals 0 when x is equal to 0, or pi, as long as we're only talking about the first, or between 0 and 2 pi. So there is our solution for the left, but we still need to deal with what's on the right. We still have more solutions to go get. So we'll do some algebra. Maybe we move this over. Maybe you call the difference of squares. I will not get into any depth about what I mean. When you get to calculus, you'll know what I'm saying. Maybe you already do. Sine squared of x is equal to 1/2. And now, with sine squared is equal to 1/2, don't do something weird here. We're going to hit with a square root. Both sides. We need to use a plus or a minus. Okay. Plus or minus, plus or minus. So there it is. Sine of x is equal to plus or minus. You know the square root of 1? 1. Do you know the square root of 2? I don't either. Square root of 2 is over there. So 1 over square root of 2, I think we know this better by, let's rationalize it and say that sine of x is equal to plus or minus root 2 over 2. Oh, shoot. Did you know the square root of 1/2 was root 2 over 2? Did you know the square root of 1/2 is the square root of 2 over 2? So now we just need to find all those x values, huh? All those x values such that sine of x is equal to either positive or negative root 2 over 2. So we start with its reference angle, which is pi over 4. Now we move to the second quadrant. That's 3 pi over 4. Now let's go to where sine's negative, down in that third quadrant where we get 5 pi over 4, and the fourth quadrant where we get 7 pi over 4. Holy moly. Looks like we got 6 solutions to this problem. What's 2 times 3? Neat. That'd be the most you could get. Moving on, going to the next, and here we go. Let's do something off to the side real quick, and let's let y equals sine of x, just so we can look through this problem, because this is an algebra problem. So instead of saying sine, we're going to go, this is 2 something squared minus 3 minus something plus 1 is equal to 0, and that something is a y. So what do we got? 2y squared minus 3y plus 1 equals 0? Hey, it's factoring. Woohoo! Know what I mean? Factoring with that leading coefficient, we must love it. This one you can just look at and find the dang answer. You can know how to do it. But I don't know about you, but this used to throw me off quite a bit. So I'm going to just do something real quick with it. This is a trick. It's an algorithm. Take it or leave it. I'm just going to show it. So if we were to take 2y squared minus 3y plus 1, nothing is equal in the meantime. This is a bullshit trick. It's basically using your what's it called? The diamond method. Since 2, 3, and 1 don't have anything in common, we can't factor anything out, we can use this method. So that 2 is the issue. I don't like that 2. It's looking at me freaking funny. It's like, I don't like it. I could factor normally without it. So what we'll do is we'll take that 2 and we'll multiply it by the 1 and it becomes a positive 2. Now we'll factor. All right, that's not so bad. This one, factoring this isn't bad. You should know how to do that. And now, shoot, we got to that point. So we get rid of the 2, we bring it out to the last piece, the c. We multiply them together. We factor as it says, but then once you're done and you get it factored, bring the 2 back. And we're going to make that the denominator of both pieces. And then we reduce. So 2 over 2 is just 1 reduced. One of them will always reduce. And then we'll just bring that 2 up and it'll become the coefficient. So there it is. 2y squared minus 3y plus 1 is actually equal to y minus 1 times 2y minus 1. All right, cool. Factoring. Algebra. Shit you should already know before ever even taking this. I'm not saying you should know this method. Oh, and just saying, this method here, take it or leave it. This is just some bullshit trick your teacher does. It just works. Take it or leave it. That is, if you know how to factor, just keep frickin' factoring. Keep factoring. Don't change anything because I showed you a method if you're not comfortable with that, okay? So we're going to use this fact down here. That's true. So we can now say that if you were to go and replace everything, we said let's let y equal sine of x, we could go through and say that this is sine of x minus 1 times 2 sine of x minus 1. Or we could actually say that this up here is sine of x minus 1 times 2 sine of x minus 1, and set that equal to 0. The game is you have to recognize that this is in the form of a quadratic. You have to recognize that this is the same thing as like 2y squared minus 3y plus 1 and know how to factor it, set it equal to 0, and solve. Now that we have this, we say sine of x minus 1 is equal to 0. And 2 sine of x minus 1 is equal to 0. That would be a solution. We move our 1 over, sine of x is equal to 1. I'm not even going to show my steps. Sine of x is equal to a half. So if you know how to do the algebra factoring, the trigonometry is not that bad. This is the basics. It's your algebra skills that are going to be tested. Therefore, sine of x equals 1 at only one place on the unit circle in between 0 and 2 pi, and that is at pi over 2. Sine of x equals a half. Well, the reference angle for that is pi over 6. And since sine is positive in the first and the second quadrant, the other angle in the second quadrant that has a reference angle of pi over 6 is going to be 5 pi over 6. There are your 3 solutions for this one. See, we didn't get 4. 2 times 2 is 4, but we could have gone up to 4. We could have. It just happened to be that this one only had one solution. And to the last one. Too much, too soon. Tough problem. I like it, though. Here we be. We're going to mix up some identities along with doing some factoring. Oh my gosh, is it going to be a great time. Don't beat yourself up if this one doesn't make a whole lot of sense right off the bat or if it's too many steps. If you do, frickin' get your hands up in the air. Do a little bravo, bravo. You're a beast. Because we want to think about these words as variables, I don't want 2 frickin' variables. So what if I was to do this? 3y squared minus 2x minus 4 set equal to 0. And I say, all right, tangent x and secant y. I shouldn't be using x's and y's there. That's such bad form since there's x's in there. Hold on. I just noticed what I did. I'll call it z. And be like, go solve for y. Give me a number. I'm like, dude, I can't. There's only one frickin' equation. There's 2 unknowns. Now, if they were all y's in there, if that z was a y, well, shit, then we can solve it. The problem is we got 2 frickin' variables, only one equation. If there was only some sort of way we could change tangent squared into things with secants in it, man, that would make life easier. But dude, tangent squared of x plus 1 is equal to secant squared. That shit ought to get that shit all memorized up. So we could change secant squared into a tangent squared. We could change tangent squared into a secant squared. It doesn't freaking matter. We just got to change one of them. So since we have the secant squared is equal to tangent squared of x plus 1, why don't we replace it? We just change secant, and we leave everything else alone. Well, cool. Let's see what happens. Let's do some algebra. Oh, this problem actually isn't that bad if you see the trick. Never mind. I thought this was going to turn into a crazy factor as well. It's not. This one's actually going to turn out pretty mellow. This one isn't going to be bad at all. All right. So there we have, we brought that 3, distributed it in. Now let's just put our like terms together. We got 3 of those thingies minus 2 of those thingies. I think we're just left with 1 of those thingies. And by thingies, I mean tangent squared of x. Now here you also got your positive 3 and your negative 4. That must be a minus 1. And we set that thing equal to 0. You could use the difference of squares here and set up your zero product principle really simply by writing tangent of x minus 1 times tangent of x plus 1. But I'm assuming most students will not do this. So this is, if you want to bring this thing over, you better remember to hit it with a square. When you hit it with a square root, you use your plus or minus. You can do that. Using a difference of squares removes any sort of change, right? If you were to take this and call this tangent of x plus 1, tangent of x minus 1, there's no way you're going to commit sign error when you do the zero product principle. But if you go this method, you absolutely could, because it's up to you whether you put that plus or minus out front. So we get that tangent of x is equal to plus or minus 1. So we don't really care. Well, tangent equals 1, where sine equals cosine. Now that's pi over 4. And since there's a plus or a minus, it's telling us we're going to be able to take all of them in every quadrant. So we're like, there's pi over 4 in the first, 3 pi over 4 in the second. That's where tangent of x would be negative 1. Then we get 5 pi over 4 in the third quadrant. That's where tangent of x would equal positive 1. And then 7 pi over 4. That's where tangent of x would equal negative 1. Or tangent of 7 pi over 4 would equal negative 1. Lots of words really fast. Did you catch them all? Here's your answer. Factoring. Simple factor. So I know it's a lot. Keep grinding. I'll come back with a couple other ones to play around with, and then we'll be off to our 2.4, 2.5. We'll go take our next test. Yeah, buddy. See you.